A tesseract. Let's understand it. First, what is a tesseract? A tesseract is a 4D shape that has equal values for the length of each dimension. That doesn't really help, so let's see if we can use our understanding of 3D shapes to see if we can graph a 4D one. If we go from a 0D object, which is a point in space, to a 1D object, or a line, we can simply double the amount of points and slide across a new axis, like the x-axis, like this. From 1 to 2, we double and use the y-axis, and then from 2 to 3, we use the z-axis. We can simply double the points once more and slide along another perpendicular axis, which we can call the w-axis. Let's try it. And boom, a 4D object. Great. But wait, this w-axis is only an illustration. It's not really perpendicular to the other axes. However, because this image is being projected onto a 2D computer screen, the z-axis isn't perpendicular to the x or y-axis either. Seeing this in 2D makes it clear. We can understand that the red z-axis line represents depth, even though this graphing calculator only supports 2 dimensions. However, don't worry, there is another way we can verify if that object is 4D or if it can represent 4D object with cross-section. With cross-section of any object is the shape you get when you fully cut through said object. Let's look at the cross-sections of cubes, squares, and lines to see if we can find a pattern. As we can see, the cross-section of an object is always in one dimension less than the original object. Therefore, the cross-section of a 4D object must be in 3 dimensions. We know from before that adding an axis means adding a dimension, so removing an axis must mean removing a dimension. Because a cross-section is a removal of one dimension, this means that removing an axis should yield a cross-section of the shape. Let's try finding the cross-sections of our 4D shape to see if we get 3D one. Perfect. They're all identical 3D shapes. But what's that, I hear you thinking? They're not all the same shape? But what if I told you they are, but you're just thinking in 3D? Let's illustrate this idea with a square. Here's a square. If I shift the perspective like this, we can also agree that it's a square. Let's visualize this in 2D instead. Here's the same square. By shifting the endpoints of the square in more or less the same way as the other transformation, the square becomes a parallelogram, but only because we're visualizing it in 2 dimensions. But by adding our 3 axes, we can perceive the transformation as a 3D one, and see that both the square and the parallelogram are the same shape. From a viewer who could not see in a 3D perspective, they would not be able to realize the square and the parallelogram are the same shape, because we rotated it in a dimension beyond the second dimension. Only by visualizing this in the third dimension can we understand that the square is still a square after the transformation. In the same way, these 3D shapes are not the same shape if we view them from a 3D perspective, but from a 4D perspective, we could say that these shapes are moved into the fourth dimension. Let's visualize this movement. Here we have two 3D objects connected along the z-axis, effectively forming a 4D shape as both are separated from each other by one dimension. By changing the perspective, it appears like the green shape is inside of the purple one, but this only because the green one is farther away from the camera than the purple one is. But by changing our perspective, the purple shape now falls inside the green one. This is in essence what is happening with the Tesseract. The inner cube is not moving in or out of the larger one, but the whole thing is instead being rotated a lot like this object. That's all I have to say, and thanks for watching.